Hey YouTube, welcome back to Trigonometry. This is a revision, and here we're gonna go through 3D problem solving. That's basically 3D solids. Within each we need to figure out the sides, or probably we need to calculate the angle. So that's all about trigonometry. Just a quick reminder about trigonometry that it always have to deal with triangles, so make sure you can find triangles there within complicated shapes within 3D solids. So try to find 2D triangles, which is flat, and within triangles try to apply trigonometry in the way of ratios probably, or you can also figure out Pythagoras. That's actually very often applicable here. Alright, so that's revision, and we're gonna go through 3 problems. That's problem 1. You can have print screen, make a screenshot, and then try by your own. After that, we go through explanation. So that's problem 1. This is problem 2. And the last problem 3 concerning pyramids. Okay, make sure you're familiar with all those shapes. And we're gonna start right now. Okay, so problem number 1. Here is the cube with sides of 10 centimeters each. Because it's cube, so all sides are equal. So we can even mark that each side is 10 centimeters. So what we need to find? We need to find AC. So the first, I'm going to connect with the green line vertices A and C. That's going to be the side that we are going to find. So which way we can find the side AC? Alright, that's an interesting problem. However, if you have a look at the triangle, let's consider a triangle. So first try to find AC. So AC is a known. So let's have a look at the triangle. So which triangle we're going to explore? Let's say ABC. ABC. So what sort of triangle? Because this is the cube, those two sides are equal. So that's why this sort of triangle is isosceles. That's first. So that's why AB and BC are equal, and each of length of 10 centimeters. So this length also 10, so I indicate with that arrow. Okay, so because we have also a right angle triangle, because each face of the cube is simply the square, and hence AB will be perpendicular to BC. So we have isosceles and right angle as well. So what we can use Pythagoras. So if you can see that triangle right there, so it will represent two equal sides, and let's say the side which is hypotenuse. So in this case, this triangle is simply that one. B is the vertex. So here is, let's say, A, and here is C. So how to figure out AC? If each side AB and BC by 10 centimeters, you can set up Pythagoras. So AC is going to be square root of 10 squared plus one more 10 squared. It's going to be 100 and 100, so literally to say that AC is square root of 200, or 2 times 100, that means it's 10 square root of 2 centimeters. Alright, so we figure out the first one, and that's going to be a result. So we found AC, it's right there. Alright, let's move next. And the second part, we need to find angle ECA. So ECA, ECA. So first of all, we need to connect. I'm going to use, say, red color. I'm going to connect vertices E and C. Okay, so what actually the angle ECE? Basically, this is the angle between the EC line and the base. If you consider base ABCD as the top one, the top base, so EC will have a projection AC on the base ABCD. So remember, just what do you know about projections? So we're doing B part, and here we need to figure out projection. So basically EC will have a projection on the base A, B, C, D. So how you perceive projection? If you have the light that goes from the bottom part of the cuboid or the cube, like in this case, and it shines, so that's parallel basically beams of the light, it shines onto EC, and EC is simply a stick. It will cast the shadow as AC. In this case, the shadow is called projection. So you just can't remember vectors if you already covered this topic. So this object is already has projection on two axes, y and x. So if we consider vectors in 2D space. In 3D space, we need to have one more dimension. So actually it's going to be projection on x-axis, on y-axis, and on z-axis. Okay, in this case, that's the same. If you consider a vector, so segment EC as the vector, that's going to be projection on that plane, which is here, okay? A, B, C, and D. All right, so I hope you understand. If not, just make sure you watch that video about vectors, about their components. So it's highly recommended to watch that. But now we're gonna go back to the angle. So ECA is gonna be that angle between AC and CE sides, okay? AC and EC are basically arms of that angle. All right, so let's mark as theta. How to figure out? Again, we do have a right angle triangle. So we consider triangle ACE with angle A, or basically angle EAC to be 90 degrees angle here. Okay, so that's why triangle AC is right angled. So we can apply trigonometric ratios. How we figure out angle theta. So right now we know AC. We did it at the first part of the question. So we know AC, and AC is going to be adjacent side. So I mark that AC, which is green one, as adjacent side in the triangle AEC. So what we also have, we have AE. So AE is 10 centimeters. If we're gonna use that within that triangle, so we can simply figure out that we need to use opposite to adjacent side, which is tangent. So we can set up tangent theta. Just remember trigonometric ratios, and it's going to be opposite to adjacent side, which gives you simply tangent theta. In our case, it's going to be EA to AC. And once we plug the values, we'll get the ratio 10 over 10 square root of 2. Okay? So from where we can simply take the 10 minus 1, basically inverse function. So now, in order to find theta, we're taking 10 minus 1 using calculator of the ratio. So 10 and 10 will be cancelled. In this case, I'll get 1 over square root of 2, and that's going to be the angle. So let's go to second set on your calculators. So take 10 minus 1 of 1 over and then take square root of 2. So we've got around 35.26 degrees. Okay, that's going to be the answer for the angle ECA. Alright, so that's the final angle. Angle ECA is going to be angle theta, and that's the value for that. Alright, so that was the basic actually problem. Make sure you be able to do that, otherwise you won't be able to do more complicated problems. So in the next video, I'll consider problem number 2. I hope for that time you already have solutions. That was Daniel Dallas. Thanks for a subscription, guys. I really appreciate that. And see you later.